All right, so let's try to answer this question. Now, the function below is continuous for which intervals? Now we have this function. Now, what this is saying is just, we should find the domain. So we need to find the domain of the function first. Okay, we find the domain of the function, and we see that we have two. In fact, we have a fraction. Okay, we have a denominator, and then we also have a square root function. So we take it one by one. So I'll start with the square root of function. Okay, where we have x squared minus 25. So for this, to find the domain of this square root function, we know that what's inside the square root should be greater than or equal to 0. So it means that x squared minus 25 should be greater than or equal to 0. Now we can take this as the difference of two squares. This becomes x squared minus 5 squared is greater than or equal to 0. Then we can use x plus 5 bracket x minus 5 is greater than or equal to 0. Okay, because this is a difference of two squares. Remember, a squared minus b squared is same thing as a plus b, a minus b. So it's the same thing. You have x plus 5 bracket x minus 5 is greater than or equal to 0. Now, remember, this is multiplication, right? So again, let's say we have a times b is greater than or equal to 0. For this ought to be true, it's either a is greater than or equal to 0 and b is greater than or equal to 0, or a is less than or equal to 0, okay, and b is less than or equal to 0. So both of them should be greater than or equal to 0, or both of them should be less than or equal to 0. For this to be true, for the product of the two of them to be greater than or equal to 0. So this means that, so let me come down here, means that I can say x plus 5 should be greater than or equal to 0, and x minus 5 should be greater than or equal to 0, or x plus 5 should be less than or equal to 0, and at the same time, x minus 5 should be less than or equal to 0. So let's take them one by one. Okay, I'll take this one by one. So we have x plus 5. So I'm just going to put this here. Let me draw a line to demarcate. Okay, so we have x plus 5 is greater than or equal to 0, and x minus 5 is greater than or equal to 0. We move this to the other side, this becomes x is greater than or equal to negative 5 or minus 5. At the same time, x, move this here, is greater than or equal to 5. So look at this here. X, okay, can you think of a value that where x is greater than a negative 5, and at the same time, x is greater than or equal to 5? If we combine these two together, okay, we would get x is greater than or equal to 5, because for a value, okay, for a value to be greater than or equal to 5, it's automatically greater than or equal to negative 5. Okay, so since this is an and, okay, it's and, so a value that is both greater than a negative 5 and greater than 5, so it's automatically a number that's greater than or equal to 5. So we combine the two of them and we get this. Okay, now let's go to this one. We have x plus 5 is less than or equal to 0, and x minus 5 is less than or equal to 0. Remove this here. This becomes x is less than or equal to -5 and x is less than or equal to 5. So again, we can combine these two. Okay, if we have x is less than or equal to -5 and at the same time it's less than or equal to 5, so it's definitely a value that is less than or equal to -5. Because let's assume you pick a number like 2. Okay, 2 satisfies the fact that 2 satisfies x is less than or equal to 5, but it doesn't satisfy x is less than or equal to -5. But say you pick a number like -12. It does both. It is both less than or equal to -5 and less than 5. So we can combine these two, okay, and say x is less than or equal to -5. All right, so we have that. So from the square root part, we have that x is greater than or equal to 5. Also, and x is less than or equal to -5. And if we draw this on a number line, we have something like this. We can say we have 0, -5, 5. We can put a circle here, shade it because 5 is included. We go like this. -5 is also included. We go like this. So for the domain, x is less than or equal to -5, x is greater than or equal to 5. And if we decide to pick it, let's just test it and see. So I'll just try and test it. Let's say we pick a number 1. Let's see what's going to happen to this function. If let's say x is 1, we're going to have 1 squared minus 25. It's going to be 1 minus 25. It's going to be the square root of -24. Undefined. It doesn't exist. Error. You're going to have an error. Okay, generally it doesn't exist. So you can see if you pick a number here, it's not going to work. So our domain will be x is less than or equal to -5, x is greater than or equal to 5. All right, and then if you want to use the interval notation, you have from infinity, negative infinity to -5, which is included, union 5 infinity. Like you don't have to put a square bracket for infinity. It's not necessary because infinity doesn't have an end, so you can't really kind of include it. All right, so let's go to the second one. Let's go to the denominator here. Okay, now this function is going to be undefined when so x squared minus 2x minus 15 have x squared minus 2x minus 15. Now generally this function is going to be undefined, okay, when this is equal to 0. So actually we don't want this to be equal to 0. Okay, but let's solve this. Now this would be okay. So the coefficient of x squared is 1. 1 times -15 is -15. So think of two numbers that if you multiply them together, you get a -15, and if you add them together, you get a -2. And the numbers I can think of are -5 and 3. You multiply them together, you get a -15. If you add them together, you get a -2. So I can do x squared minus 5x plus 3x minus 15 is equal to 0. Okay, we can start to factorize, put them in brackets. This x is common, this is x minus 5. Okay, plus 3 is common here, 3 x minus 5 is equal to 0. So we have x plus 3 bracket x minus 5 is equal to 0. So it means that x plus 3 is equal to 0, or x minus 5 is equal to 0. This means that x equals -3, or x equals 5. So it means that x should not be equal to -3. X should not be equal to 5. Okay, now let's try and combine everything so far. So from the top, we got our, this as our domain. We had x is greater than or equal to 5, x is less than or equal to -5. Let's bring it here. X is less than or equal to -5. X is greater than or equal to 5. You can see here, x is not equal to -3. Now, a -3 falls between these two areas. So -3 falls around here, right? So it means that we can simply ignore, because we don't even need, it's already not part of the domain. So we don't, what do I say? You can ignore it, okay? Because it's already been ruled out here, okay? Because we said x is greater than or equal to 5, x is less than or equal to -5. So having a -3 here, it has already been ruled out. So you can actually take this out. Okay, it's not, we can take this out. Now x is not equal to 5. Now remember, we have where x is greater than or equal to 5. So if x cannot be equal to 5, it means that this now becomes x is greater than 5, because x cannot be 5 because of the denominator here, right? X cannot be 5. If we combine these two, it means that x has to be greater than 5. It cannot be 5, because if it's greater than or equal to 5, yes, it satisfies, the top function. But when we consider the bottom function, the denominator here, once x is 5, this becomes undefined. So we have to take away the equal to part, and we're left with x is greater than 5. Now what we have left is x is less than or equal to -5, and then x is greater than 5. I put all here, and this will be the domain. Okay, x is less than or equal to -5, or x is greater than or equal to 5. And if you want to use the bracket notation, you have something like this. This goes from -infinity to -5, which is it's included. Union 5 is not included, and then infinity. And if you plot this on the graph, so let me get a graph. Let me show you the graph from Desmos, so you can see what. Okay, I'm gonna share my screen to share. So as you can see here, we got x, okay, is less than or equal to -5, or x is greater than 5. You can see we have what we call a vertical asymptote at 5. It doesn't, you can see this line, yeah, it doesn't touch 5. Okay, it gets closer and closer to 5, but it never actually touches 5. Let me kind of zoom in so you can see. Sorry, I can zoom in. If you zoom in, you see that it doesn't, the more you zoom in, you see that it doesn't necessarily, it gets closer and closer to 5, but it doesn't touch 5. Okay, we just keep going up, up, up. I can see gets closer and closer to 5, but it doesn't necessarily touch 5. But on the other side here, where we have a negative 5, you can see it actually it touches this point here. You can see it actually touches this point at -5. And we have a okay, we have okay, we have a continuous function. You can see it just keeps going like this, and for this other side, you can see it just keeps going this way. It just keeps going. So we can establish that. Let me go back to my whiteboard. So we can establish that the function below is continuous for these intervals. Okay, these ones here. You can write it this way, or you can write it this way. So it's a choice. The idea is that you are looking for the domain of the function. So that's it. I hope I've been able to explain it well, and thank you, and have a nice day.